discuss how to conduct an exergy analysis in order to determine the maximum work that could be harnessed from a given system. Okay? In addition, we will discuss about the change in exergy and how to conduct an exergy balance for closed and open systems. So, let's start with the change in exergy. Change in exergy. Okay. What is this about? Okay. We all know that if this is your system, you have an exergy, and if this is your environment, okay, during a process, the system undergoes a change, right? So, mo-change niyang yung exergy, no? As long as kaning imong system dili pa maabot dire, napa na siya exergy. Okay? But kung abot na sa dire, zero na yung exergy ana. The question is, what is this one? The change in exergy. So, in order to get this one, recall that exergy is just the energy of the system minus U sub O, and then plus PO V minus V sub O, right? Minus, okay, this is the exergy of your system. Okay, but napa ni siya plus the kinetic and potential energy, right? So, butang natin yung arrow plus GZ. Okay. Now, if this is your, how do you evaluate the exergy at point 1? So, this is your exergy at point 1. So, nanikaro yung mga subscript ng 1. And the exergy of your state 2 is energy at 2 minus No. If we use this one, wala na ni. Ano man, kay compose man yung kinetic, potential, and internal energy. Okay, plus PO okay, then you subtract E sub 1 from here, you will get this equation. Plus, now is this one, PO V2 minus V1 minus TO. Okay, that will be your change in exergy. Okay? Okay. What if you want to relate, okay, no, as ang imong system if this is your system, this is the environment, no, as it undergoes a process na siya accompanying heat transfer and energy transfer by work. Okay? And ang imong exergy is also transferred using this mode. Okay? Na ay gitawag og exergy transfer by heat and exergy transfer by work. Okay, and also naapod na siya yung mga part po sa mga exergy nga ma-lost or due to irreversibilities. Okay, so that is what you call the exergy destruction. So kana siya nga mga concepts dili na makita diri nga equation, no? So we need to get the exergy balance for a closed system. Exergy balance for a closed system. Okay, how do we get that one? First, we will use the energy equation, the first law of thermodynamics. Change in energy is just equal to work, heat minus work, right? Or and we'll use this one, the change in entropy. Later on, masabtan na nato ng anong kaniya itong gamiton. Okay? Okay, kaniya itong gamiton. Again, ang atong objective is to get the exergy balance for a closed system, which relates the exergy transfer by heat and work and the exergy destruction. So let's multiply this one by T sub O and subtract kandari. So gawin na lang natin isulat. You will have E sub 2 minus E sub 1 minus TO S2 minus S1. Okay, is equal to minus T sub O minus T sub O dito na hindi pasuldan na to, minus T sub O over ito na lang yung i-kuan dere yung subscription ng temperature minus work minus TO sigma. Okay, so muna siya, and then sa itong bottle na ang atong objective ani is makuha na to ni sa ang value ani, no? So diri na siya, right? By the way, kani nga term is mo naman ni dili kani and kani mo na siya, no? Therefore Kani, ato i-simplify ni, mahimo na ni. Ato na i-collect no, kay same sila og differential. Mahimo ning 1 minus TO T sub B. Right, minus work minus TO sigma. Okay? So, kaning equation na yun, mahimo na dahil niya siyang change in Exergy is kaning nga term atong i-substitute diri. Kaning man ako. Mahimo na ng 1 minus TO and then minus work, right? Collect na tong work and then ani positive minus kani. Okay? Again, kani siyang equation ni karon ni diri kani nga term mong i-plug in diri. Man nako ano man ni. Right? So mo na niya imo ang this is now your Exergy balance for a closed system. Ani mo ni ang this is the Exergy change. Exergy change as yung system from point 1 nabot sa point 2, no? Unang yan corresponding Exergy change kay posible mo gamay, posible mo dako man ni siya, no? Siyempre mo dako ni siya kung magkalayo gali ni siya sa no, mo nitiman na no, magkalayo gali ni siya nga point sa imong environment, magdako Exergy. Magkaduol ni diri gamay na yung value ano man, duol naman sa iyang environment, no? And then kaning nga term Exergy transfer kani Exergy destruction, no mo na nawala nga Exergy kani mo na ang Exergy transfer by heat accompanied by the heat, no? Heat transfer kani by work kani siya nga term. Okay? Okay. Now, take note nimo nga may ang itiman na nani. By the way, kaning nga term TO sigma is equal to E sub D. Ani. So, ang value ani niya is greater than 0 or equal to 0. Dili na pwede nga man negative. Kani Exergy change pwede na siya pwede ni greater than 0, equal to 0, less than 0, pwede ni maging negative. Okay? Okay, in the book na kay other forms of Exergy balance kung ano po na siya with respect to time. Anyway, tanaw na ninyo siya. The same naman na siya. Murang i-divide by ano yung change in Exergy respect to time is equal to from 1 Q sub J minus work. Okay, so with respect to time na siya. Okay, for an isolated system, di ba? Ang imong Exergy change is 1 minus Q, right? Minus work. Minus POV minus Exergy destruction, right? So for an isolated system, since wala man na yung work, wala po yung heat transfer, zero ni. Therefore, ang mabilin is kanina lang. Change in Exergy is just equal to negative Exergy destruction. Okay? So, muna siya for an isolated system. Okay, so unsa may ang item man ani? Okay, for Exergy transfer by heat, for Exergy transfer by heat, no? Say for example, nani sa yung book, no? Morning mo ang dead state or sa state sa imong environment. This is your initial state, no? T1. Okay. If T1 is greater than T sub O, if T1 is greater than T sub O, meaning mas taas ang temperature sa imong system compare sa environment, heat transfer and Exergy transfer is in the same direction. No? Same sila direction. Meaning same sila sign, di ba? Now, kung if initial nimo is less than TO, usually sa refrigeration nimo, no? Ang temperature sa imong system is much lower than the environment. So opposite na sila karon. Heat transfer and Exergy transfer is in opposite direction. Opposite direction sila. Okay, always remember na kung magkaduol ka, paduol sa imong dead state, mugaman yung mga Exergy. Kung magkalayo ka, taas. Anyway, we will have an example in order to illustrate this one. Okay, let's take an example, and this is taken from example 7.3. Okay. Tub of water, initially a saturated liquid at 100 degrees Celsius, is contained in a piston cylinder assembly. The water undergoes a process to the corresponding saturated vapor state, during which the piston moves freely in the cylinder. For each of the two processes described below, determine on a unit mass basis the change in exergy, the exergy transfer accompanying work, exergy transfer accompanying heat, and exergy destruction. The temperature and pressure of the environment is 20 and 1.014 bar. Okay, so this is the first process. Change in state is brought by heating the water as it undergoes an internally reversible process. At constant temperature and pressure. Now, the second process is the change in state is brought about adiabatically, meaning there is no heat addition, by steering the action of the paddle wheel. Draw the system. You have a piston cylinder assembly. Okay. And then you have water. Now the initial state is given. Okay. State 1. For state 1, you have temperature 100 degrees Celsius, and it's stated that it is a saturated liquid. Okay. For state 2, the same temperature, but the water becomes saturated vapor. Okay. Question is, what is the change in exergy? Now recall that the change in exergy is for per unit mass basis, no? This one, small letter E. Just UG minus UF, or U2 minus U1, plus the pressure in the environment, specific volume, minus TO SG minus SF. Okay, so kaning mga values kita ra nimo ni sa table. Okay, this one kini UG minus UF is just equal to 2087.56 plus 1.014 bar. Convert this one into kilopascal, so this becomes 1 bar 100 kilonewton per m square times the Vg minus Vf, again nara ni sa table, 1.672 m cube per kilogram. Okay, so ang resulta ni nga unit will be kilojoule per kilogram minus T sub O 100 is plus 273. Ano? T sub O is 20. This is just 293.15 Kelvin. Okay? 293.15 times G minus SF Kelvin. Okay, so the change in exergy is 484 kilojoule per kilogram. Okay? Okay, giinit man siya, giinit. Pag init ano niya, imong vapor, expand ang imong kuan karon, vapor ang imong water. Expand ang volume. Okay? Okay, so ngayon dali nga this is an internally reversible process. Okay, let's proceed with the Exergy transfer accompanying work. And the equation for that is this one. The work minus POVG. Okay? Okay, now this one, kaninga work, this is the work done by the system, right? Pag expand na niya, ka-create na siya work. So may tabuan sa may work alin niya, at constant pressure man so P is just again Vg minus Vf minus PO Vg minus Vf. Now recall na kaning ang sa imo ang TV diagram malimong FG. Note that ang saturation pressure aning 100 is 1.014 bar, the same sa imong environment. Therefore, ano na siya? P minus PO is equal to 0. No exergy transfer by work. Okay, 0 na siya. And then exergy transfer by heat. By heat na sad. Again, equation is 1 minus TO over TB times Q. Right? Or Q over M. Okay. So, sa may tabuan Now, let's find what's in Q. Of course, kaning Q mo na yung ganing supply ni Madere. And that is just equal to the Q is just equal to the change in kani latent heat of vaporization, no, over M. Therefore, Q over M is just 2000. By the way, kuan man siya. This is just a closed system. This is a closed system, so you have 2087.56. Okay, so muna yung multiply dito 1 minus 293.15 over kaning 100, 373.15 times. Therefore, ang answer is 484. Okay? And then, the Exergy destruction is 0 nga naman. Because internally reversible process, or you can also check using the Exergy balance. Right? You can also check using the Exergy balance kung zero bagod siya. Okay? So kung tanawon, kung gamitin na ito ang Exergy balance sa metabo, you have the Exergy change, and then by Exergy transfer by heat. By heat is 484. 484, and then minus Exergy transfer by work, which is 0, minus Exergy destruction. And then kani siya A2 minus A1 from previously nga nakuha na to. This is just pila siya dapat value. Dapat ang value ni kaganiya is 484 man ni. Therefore 0 bit siya. Okay, for letter B, ang process adto is the change is due to steering of the paddle wheel. Okay? Steering of the paddle wheel. So for the Exergy change, E2 minus E1 for letter B, the same ra siya naman. Kaya the same raman siya og state. Same state. Ang Exergy nimo is a property man sa imong system. So for, or pwede mo solvon, but again, kanina gigihapon mo makuha. And then Exergy transfer by heat. Exergy transfer by heat is 0 nga naman, adiabatically. No? So Exergy transfer by by work. The equation is work over M minus EO VG minus VF. Okay? Exergy transfer by work. Okay, since kung nakay steerer dere, input na work. Input na work, no? So unsa ang value ana niya? Ang value aning work over M, the value of work over M, ang work dere, applyan nimo ning first law, Q minus work, right? 0 man ang 1, so therefore ang work nimo is just negative of UG minus UF, or this is just, by the way, work over M. This is just negative 0.56. Okay? 0.56. Negative because pasod sa system. Ito nang ibutang nire, negative minus 1.014 times 100 kPa times 1.672. So answer ani is negative 1257 kilojoule per kilogram. Okay? So the minus sign indicates that the net transfer of Exergy accompanying work is into the system. No? Negative Exergy transfer, may password man po na imong work. Lastly, Exergy destruction. So, para makuha ang Exergy destruction, we need to use the Exergy balance. Delta E minus itong sa work, no? Exergy transfer by work. So you have 484 minus minus. So ang answer ani will be 2,000. Oh, by the way, negative. Okay. Kaya itong i-derive ang equation na delta E is equal to by heat 0 by work. By work minus ED. Specific kaso ba negative delta E. Okay, negative din dapat. Negative. So ang answer dapat positive 1773 kilojoule per kilogram. Okay? So that's it. Later on we will proceed with open systems.